Hi everyone, I'm Tim Lancaster. I'm with GrassWorx InstaTurf out of St. Louis, Missouri. GrassWorx has been manufacturing AstroTurf-based products in St. Louis for a little over 30 years now. I came to the company about 2 years ago. Before coming to AstroTurf, I was with North American Green for a little over 28 years. And some of the products you will see here today, I personally helped develop. So before we get into the products, I want to give you a little background on turf reinforcement mats, or as they're known in our industry as TRMs. Now, the Erosion Control Technology Council has a definition, a published definition for TRMs, in that these are rolled erosion control products. They're made from primarily non-degradable fibers or filaments. And these types of erosion control products are typically used in high flow applications, very steep and high flow channels, steep slopes, stream banks, shorelines, basically in applications where the long-term erosive forces are going to exceed the limits of natural unreinforced vegetation. Now, the difference between a TRM and an erosion control blanket. An erosion control blanket is made from degradable materials. These products are used on a temporary basis to primarily control erosion and provide a mulching layer for vegetation establishment. But once the vegetation establishes, these products are expected to degrade. Erosion control blankets typically are manufactured from degradable natural fibers such as straw, coconut fiber, wood excelsior, and those materials are usually stitched into or between a photodegradable or natural fiber netting. Permanent turf reinforcement mats, on the other hand, these are made, as I just said, from non-degradable materials. And these types of products are typically used not only to provide the initial erosion protection to get vegetation established, but they are meant to basically stick around long-term to reinforce the vegetation and increase the vegetation's erosion resistance. So if we look at how modern TRMs perform in basically increasing the erosion resistance of vegetation, this chart shows us, or this table shows us, the permissible shear stress ratings for different materials. And unreinforced vegetation, according to the USDA, has a permissible shear stress rating anywhere from, on the low end, 2 pounds per square foot up to 7.5 pounds per square foot on the high side. And those ratings are basically dependent on the vegetation itself, the stand height, the density of the stand, but as well as the type of soil that the vegetation is growing or anchored into. TRM reinforced vegetation, and these numbers are based on manufacturers' published values for the various products out there. Typically range anywhere from 10 pounds per square foot up to 16 pounds per square foot. And that's vegetation that's reinforced with the turf reinforcement mat. That's mature vegetation. If you compare those values with, say, rock riprap, Federal Highway Administration's permissible shear ratings for various sizes of rock. A 24-inch rock has a permissible shear stress of around 10 pounds per square foot, or just shy of 10 pounds per square foot. And 36-inch rock goes all the way up to past 14 pounds per square foot. So this chart shows us that TRM reinforced vegetation can compete with rock riprap, but that is assuming that you have mature vegetation working in conjunction with the TRM. If we look at some of the benefits that TRMs provide versus using hard armor such as rock, One, TRMs basically allow you to use more vegetation on your construction sites. So it allows for a greener construction site and all the benefits and ecological, environmental benefits that vegetation brings versus using a hard armor material. Another benefit of using TRMs is they're typically less expensive than using, say, rock riprap. Typical install cost for a TRM is going to be less than 50% of that of rock riprap. And the other thing is with these products, you don't need heavy trucks or to transport the materials to the job site, and you don't need the heavy equipment, the backhoes and excavators that are commonly used with installing rock riprap or concrete-based materials. TRMs, once they vegetate, they can simply be mowed over, so they're fairly easy to maintain on a long-term basis. And then from a hazard standpoint, using vegetation along roadways and pedestrian areas where people walk, they're just a lot safer than using a hard armor layer such as rock riprap. And then from the environmental side of things, with vegetation, you get increased stormwater filtration as well as infiltration into the soil. And then the vegetation itself can basically act in the natural habitat of the job site and provide ecological function. So I want to give you a history of turf reinforcement mats. This technology has been around for almost 50 years now. The first TRM was developed in the early 1970s. And the first product was manufactured from extruded nylon filaments. And you can see the product in the bottom left-hand corner, or bottom left-hand corner there. And that product is a very open structure, and it was made to be open like that so you could soil and seed infill the mat structure itself. And the reason for that is the concept is you wanted the vegetation growing within that matrix, so the matrix itself would reinforce the vegetation roots. Now, with the openness of that structure, the product itself didn't really provide a lot of initial erosion protection before the vegetation became established. So these types of products, when they're installed, they're often installed with a supplemental covering, like a degradable erosion control blanket, to provide the immediate erosion protection necessary. So the types of applications these products are used in: steep slopes, levees, shorelines, channel lining applications, anywhere where they can go in and install the product and then apply the soil and seed into the product. Now in the mid-1980s, the surface, what I call surface applied TRMs came along, and these products were primarily developed by erosion control blanket manufacturers. So you had these ECB manufacturers out there at the time that were basically taking nettings and stitching straw or coconut or Excelsior in between those nettings. And they thought, well, you know what, we can just basically substitute a non-degradable fiber between those nettings versus the degradable fibers and have a permanent erosion control mat. Those fibers typically consist of polyester or polypropylene. And with the application of this type of product, instead of soil filling the mat, the TRM, these products were applied directly over the seed and soil, and then the vegetation would grow up through the mat. So with this type of product and installation, the product itself, the TRM, is not really providing root reinforcement, but the term stem reinforcement was initiated at the time to kind of define or describe the reinforcement that the product's providing for vegetation. And it's not just a matter of reinforcing the stems of the vegetation, but these types of products also protect the soil in which the vegetation is anchored. Surface applied TRM applications, pretty much the same as what you have with the soil and seed infilled TRMs, channel lining applications, shorelines, steep slopes, and such. And then in the early 1990s, one manufacturer developed the first composite TRMs. And these composite TRMs were kind of a combination of a degradable erosion control blanket and a permanent TRM. So the first product that came to market was manufactured with coconut fiber that was incorporated into a kind of a triple net structure, a three-dimensional netting structure. So the coconut fiber was there to provide the initial erosion protection and mulching action. And then the three-dimensional netting structure would stick around long-term to provide the reinforcement layer for the vegetation itself. And the reason for this was the natural fibers within this product would provide more mulching or better mulching action than the synthetic fibers and the previous surface applied TRMs. And those coconut fibers also seem to provide a little higher level of erosion protection as well, at least on a short-term basis. The applications for this product, very much the same as the other TRMs I've discussed. Channel lining applications being the primary application that you'll see. And then in the late 90s, the woven high performance TRM products were introduced to the market. These are very high strength materials. In fact, in order to be categorized or classified as an HPTRM by industry standards, the product has to have a tensile strength, a minimum tensile strength of 3,000 pounds per foot. Now, with that, I'd like to note that high tensile strength does not necessarily equate to increased erosion protection. The tensile strength is there for damage resistance. And these types of products are often used where they're going to put the mat down and they expect to run heavy equipment, heavy mowing equipment over the area in times where the soil may be saturated. And these types of products are also used in applications where they want to reinforce the veneer or the top layer of soil and prevent shallow veneer failures of the soil itself. In that type of application, these high performance or high tensile strength TRMs are often installed with an earth anchor system. Applications for these products. One application that we've seen over the last several years is for levee protection. A lot of the high performance TRM type products have been used in protecting the levees that have been renovated down in the New Orleans area. And in that type of application, the material is installed. They install the material with earth anchors, and then they actually apply a layer of soil over the top of the HPTRM, and then a layer of sod over the soil itself. So those are the different types of TRMs that have been out there for quite some time. And I'm going to cover the advantages and benefits of TRMs versus using hard armor. But there is one disadvantage that conventional TRMs conventional TRMs have, and that is these types of products have fairly low erosion resistance until vegetation becomes established within the mat itself. And these types of products, unvegetated, before vegetation establishment, typically have permissible shear stress ratings ranging anywhere from 2 to 4 pounds per square foot. So full vegetation establishment with mature root systems, That process can take anywhere from 6 to 12 months or sometimes even longer in certain areas. So there's that period of risk there between the product's installation when it's unvegetated up until the time it becomes fully vegetated, where it may not provide sufficient erosion protection. Now, rock and concrete, when they're installed, they're immediately at their maximum erosion resistance. So in 2017, when I left my former employer, I started thinking about ways to improve that immediate erosion resistance of TRMs, because that was an issue that we often face with many engineers that wanted to use soft armor. They wanted to use TRMs instead of hard armor, but they didn't want to take the risk. So with these products, as I said, unvegetated permissible shear stress ratings, 2 to 4 pounds per square foot. Once they vegetate, that number jumps up to 12 pounds per square foot and sometimes even higher. But it's that period of risk there that many engineers have caused many engineers to shy away from using TRM systems. So something else that is kind of exacerbating this whole issue is climate change. So it seems like these 100-year storm events are coming about every 2 weeks now. And you see it in the headlines all the time. And I think we've all experienced the wacky weather over the last few years. And with that, higher frequency and larger storm events that we seem to be having, that's basically raising or increasing the chances of a major storm event or several major storm events occurring before these types of products become fully vegetated. So with that, in 2019, we introduced to the market a new category of products that we call instant armor mats, and more specifically, a hybrid turf instant armor mat. And these are soft armor products. They are meant primarily to replace rock riprap in your high flow applications. And these products are the first permanent soft armor mats that actually have or provide the same level of immediate erosion protection as very large rock riprap. They have between 3 and 4 times the unvegetated permissible shear stress ratings of your conventional TRMs, as well as HP TRMs. And I think of these products in the way they perform as hybrid vegetative armoring systems. So it's basically simulated turf that protects, establishes, and permanently reinforces natural vegetation. So there are 2 products that we consider instant armor mats. One, the product to the left comes in roll form, and this is the construction and being supplied in roll form makes it very similar to your conventional turf reinforcement mats. This particular product, you're going to seed first and apply the mat over the top of the seed and allow the vegetation to grow up through the simulated turf. And then the product that you see to the right is the instant armor scour mat, and that actually comes in panel form. So the hybrid turf instant armor mat, to give you an idea of how this product is made, it's basically a 1-inch thick monolithic UV stabilized polyethylene structure. And what I mean by monolithic is it's all molded into one piece. It's not stitched or glued together. And then on the back side of that, or the bottom of the simulated turf, is a very lightweight polyester geotextile. And that geotextile was specifically designed to not only trap the fine soil particles beneath the mat, but the material is light and open enough to allow for vegetation emergence and development up through it. This product actually, as I mentioned, comes in roll form, and those rolls are either 3 foot wide or 6 foot wide by 45 feet long. The 3 foot wide rolls weigh approximately 50 pounds, and the 6 foot wide rolls weigh around 100 pounds. Now, this product's going to be installed very similarly to the surface applied TRMs. So you're going to seed first and then install the mat over the top of the seed. And installation is typically done with an 8-inch wire staple. Sometimes fabric pins or rebar stakes are used depending on the soil condition that you're anchoring into. And then once the product vegetates, it's easy to maintain. You can simply mow right over the top of it. So the way this product works, there's basically 3 mechanisms at play here. One is the simulated turf itself. That simulated turf basically forms a shear plane on top of the fabric and underlying soil. And what that does is kind of deflect or lift a lot of that shear force that would normally be acting upon the soil and kind of raise that plane above the soil. So there's less force, less erosive force reaching the underlying soil surface. Then the fabric backing does 2 things. One, it basically filters fine soil particles and traps those soil particles beneath it, and keeps soil particles from being sucked or pulled out of the mat under flow conditions. And then the fibers within that fabric, particularly when it's applied to a clay-based soil, those fibers, when they get wet, they stick to the soil. They kind of adhere themselves to the soil particles. And that picture you see to the left there, you can see how those fibers are kind of stuck to the soil as we're trying to pull the edge up on the mat. So that helps trap and kind of lock the soil particles into place. So testing that's been done on this product was done under the ASTM D6460 large-scale channel testing protocol. And this product has been tested in an unvegetated state at this point. This product was tested at TRI Environmental down in South Carolina. They do all of the Ashtone NetPep testing on rolled erosion control products, any products that are enrolled in the Ashtone NetPep program. And the test protocol here, they have a 2 foot wide by 40 foot long channel flumes. They use a loam soil type, and typically TRMs are tested on a 10% channel gradient. We actually went to a 20% channel gradient with this product because we started out in a 10% gradient and had very, very little measurable soil loss. So we increased to a steeper channel gradient in order to get higher velocities and higher shear stresses in order to try to reach a failure point for the product. The mats in this test were installed with an 8-inch wire staple at 3.8 staples per square yard. And then in the testing protocol, they use 3 separate channel test flumes. And then within each test flume, they do 4 consecutive 30-minute flow events. Our discharges ranged anywhere from, I think, around 10 CFS up to 50 cubic feet per second, reaching velocities over 24 feet per second and shear stresses between 11 and 12 pounds per square foot. Through all of these tests, the cumulative soil loss from our test plots averaged 0.2 inches. And in the ASTM protocol, the failure point is set at 0.5 inches. So the product never reached failure. And the reason we actually couldn't reach failure because they didn't have enough flow discharge on their site to get any higher velocities and any higher shear stresses to get the product to a failure point. So the product actually never reached failure in the test, although we tried. So if you look at the performance of the product through the ASTM D6460 testing compared to some of the other materials that are out there, and this graph shows us cumulative soil loss on the y-axis in inches, and then shear stress or applied shear stress on the x-axis. And you see the three graph lines to the left, and those are your conventional, TRMs, HP TRMs. The light blue line is a woven polypropylene HP TRM. The kind of orange line there that you see is a double net polyfiber turf reinforcement mat. And then the light purple line is a triple net coconut fiber composite TRM. One thing you'll notice is the performance of all three of those products is pretty similar. They're all grouped fairly close together. And all three of those products are at or approaching the half-inch failure point anywhere between 2 and 3 pounds per square foot of applied shear stress. If you move to the right, you'll see the yellow line, which is a tied concrete block mat. And then the green line is the Hybrid Turf Instant Armor mat. And you'll notice that the Hybrid Turf Instant Armor mat pretty well runs neck to neck with the tied concrete block mat in terms of controlling soil loss under some fairly high shear stresses up to between 11 and 12 pounds per square foot. So we say this product gives you the performance of reinforced turf from day one. And this graph kind of shows us that the top three lines you see there, those are the conventional TRMs I just showed you previously. They were unvegetated. Here they are fully vegetated. And this is with 12 months or approximately 12 months of vegetation growth. The green line is the Hybrid Turf Instant Armor mat, still with no vegetation. And you can see by this graph that the Hybrid Turf Instant Armor mat, even without vegetation, provided maybe a little bit better control of soil loss control than these other products did with full vegetation establishment. If we look at the shear stress ratings of these various products versus rock riprap, conventional TRMs, as you see to the left, typically between 2 and 4 pounds per square foot without vegetation. On average, I would say around 3 pounds per square foot. And then once those materials become vegetated, that number jumps up to 12 pounds and sometimes even higher. The Hybrid Turf Instant Armor mat, unvegetated, actually starts out at 12 pounds per square foot, permissible shear rating. And then once the material vegetates, we're projecting right now a permissible shear of 16 pounds per square foot. You compare that with 24-inch and 30-inch rock, you can see how these materials can actually be considered viable replacements for rock riprap. So if we look at the price of these various materials versus their day one performance, we're looking at projected shear stress, so versus installed cost of these materials. And say if you have a channel lining application where your projected shear stress is somewhere between 0 and 2 pounds per square foot, your temporary erosion control blankets are typically going to fit the bill. These products are the cheapest of what I have on the board, and they range anywhere from 15 to 50 cents per square foot, depending on the type of ECB and the type of installation that's being done. Between 2 and 4 pounds per square foot, that puts you into the turf reinforcement mats and high performance TRMs. Those products range anywhere from 70 cents per square foot up to $2.25 per square foot. And the large range there of prices really depends on the type of TRM you're considering, as well as the application and exact installation details of the application. Above 4 pounds per square foot, that puts you into the hybrid turf instant armor mat. And the cost of that is typically a little bit more than the upper end of the HP TRMs. But that also puts you into the, say, the range where rock riprap is normally specified. So as you can see here, anywhere from a 12 to 30-inch rock. And 12-inch rock by federal highway standards has a permissible shear stress of 5 pounds per square foot. And the 30-inch rock has a permissible shear up to 12 pounds per square foot. So if you look at the cost of rock riprap, and these numbers are going to vary significantly depending on the project location, how far the project is away from the quarry, and how far the rock has to be transported. But riprap costs anywhere from $4 to $8 per square foot for a 12-inch diameter rock, up to over $10 per square foot for 30-inch rock. So the hybrid turf instant armor mat can certainly provide a lot more cost-effective solution for you versus rock riprap in many applications. Kind of at the top of the scale there, once you get above 12 pounds per square foot of applied or projected shear stress, that puts you into the tied concrete block mats, the TCBMs, or the articulated concrete block mats. And these types of products range anywhere from $6 to $12 per square foot installed. So if we look at the typical applications for the hybrid turf instant armor mat, these applications are very similar to the standard turf reinforcement mats, just maybe in more high flow type situations. But you're looking at channels, steep slopes, outfall areas, downshoots, shoreline, stream bank applications. And one application we've seen for this product is an overwinter project protection, where you need several months of erosion control before vegetation establishment. Say if you're putting a you're protecting a channel that is seeded in late fall, and you know that vegetation won't establish there until the following spring, and you need good protection over winter, this type of product affords that. And then also projects where vegetation establishment just may be slow in general due to the climatic conditions on the site. You know, shady areas typically take a while to vegetate, as well as areas where you have wet soils or poor soils. Now I'm going to take you to a field trial application that was done with the hybrid turf instant armor mat. And this was done with Peabody Coal Company on one of their coal mines in southern Indiana. And this installation was done in September of 2019. And they were looking at using the instant armor mat to replace a lot of the rock that they use in other areas of the mine. You can see on this side here off to the right, that big slope, that is a capped overburden stockpile or pile. And then the channel along the edge of that runs the perimeter of that stockpile. And that drains about somewhere between 12 and 13 acres. So when it rains in this area, this particular channel takes on a lot of water flow. So when we did the test installation, you can see basically a rock riprap check dam downstream from the test section as well as upstream from the test section. And then between the rock riprap check dams and the test section, we actually left that bare. And those areas were simply seeded and straw mulched. And we left those as kind of control areas to just see what would happen in those areas without the instant armor mat protection. This is a picture of the mat just after installation, looking downstream or downslope. And then I went back out to the site about a month later, and at that time we had had hardly any rainfall. So I didn't really expect to see much, and I didn't. There was hardly any vegetation that had germinated and emerged up through the mat at that point, as well as the surrounding areas that were just straw mulched. But as things often happen, 2 weeks after that picture was taken, where the mat was pretty much just bare, unvegetated, that's when the rainfall started. And on October 21st, we had a little over 1.5 inches of rainfall. And then a week after that, we had over 2 inches of rainfall in a 24-hour period. So that's when the rain started. And then by the end of October, we had had a total of 6.5 inches. So when I went out to the site later in November to see how things held up, the first thing I saw was a picture to the left. And basically several big gullies had formed in the overburden cap, as you see there. And then the channel itself, the picture in the center of the screen there, there's a lot of incising and a lot of cuts and just a lot of scour going on. And the rock riprap check dams had all took a little bit of a beating. You can see some of the rock had washed out of that check dam there, and a lot of the straw mulch that they had used around this site had kind of collected in the check dam as well. The picture to the right shows you one of the gullies that had started to form at this point as well. And that gully is probably about 3 feet wide at that point, maybe a foot or so deep. I got to our test section. I was a little concerned after seeing all the damage that had occurred in other areas. And I saw this. It was like a green rectangle of vegetation surrounded by a lot of eroded soil. So I was very pleasantly surprised and pleased to see the test section held up as well as it did. So the picture to the left is the mat upon installation looking upstream. And then the picture to the right is on November 20th with good vegetation growing up through the simulated turf. Now, one thing we didn't do during the installation is use enough of the matting to cover the entire width of the channel. So we thought when we installed the product that we had the wetted perimeter or the projected wetted perimeter covered, but we didn't, and the area that we didn't cover with the mat eroded and scoured very badly. You can see the edge of the mat there, just where the mat stops, that's where all the scour starts. And that scour, it's about 8 inches deep at that point and probably 2 to 3 feet wide. That just right along the edge of the mat, and there's just a real distinct sheer face there where the mat stops and where the erosion begins. So this is the channel. This picture was taken in December, and this is standing downstream from the test section, looking upstream. And you can see the control section just downstream from the test section. There was a big scour hole that had formed there. That scour hole is probably about 2 feet deep. And then you can see the scour that occurred on the right side slope, which is on the left side of the picture we're looking at. Stepping back from that, the test section is to the left, and then center of the screen is the control section where the scour hole is. And then there was a rock check dam just downstream from that. And at that point, a lot of that rock had started to wash out of that check dam, as you can see there. And there's also a pretty good gully, pretty nice gully that had formed just downstream from that rock check dam. Now the rocks in that check dam are anywhere from 12 to 24 inches in diameter, so fairly good sized rock that has started to wash. So it gives you an idea of just how much flow this channel must have taken on in the fall months last year. I went back out to the job site in May to see how things were doing. The test section itself had, vegetation filled in very well, greened up nicely. And at the end of April, they had come in and infilled that gully that I showed you that run along the right side slope. They had infilled that gully and straw mulched it and seeded over it. And by the end of May, on May 28th, all that infill soil had washed out again. So we had quite a bit of rainfall there in mid-month of May, and all that infill soil had washed out, and there were actually some rocks that had washed in or deposited in that gully along the edge of the mat, and those rocks were washed out of the riprap check dam upstream and found their way down into that gully next to the mat. If you look at the picture to the right, you can also see that check dam is pretty much leveled at this point in time. Picture to the left was taken upon installation, picture to the right on May 1st, and you can see how well the mat is vegetated at this point. And the good thing is that vegetation is now reinforced. So with the mat being down there at the base of the vegetation, that mat is increasing the erosion resistance of the vegetation itself. Just another look at it. This is looking upstream, and picture to the right was taken at the end of May. And once again, you can see how well the vegetation has grown and established in the test section. Another application for the product, this was done also with Peabody coal, and this is for stream bank protection. And they've got a lot of streams that they've had to construct, basically any streams and drainage areas that they disturb during their mining activities, they have to replace elsewhere. And they construct these streams. These are overseen by the Army Corps of Engineers. The Army Corps wouldn't allow them to use anything on the bottom of the stream. It had to remain open, bare soil, and primarily for the benthic organisms and such to live in there. But they wanted to protect the stream banks through the winter months. This was going in late October, so they knew that they weren't going to get good vegetation establishment till the following spring. So they wanted some pretty good protection for those banks through the winter months. This was in 2018, and between, I guess, the winter of 2018 and 2019 was very wet in this area. I think we had over 6 storm events with 2 inches or more rainfall in a 24-hour period. Every time it rained heavily, this stream valley would just fill up. It would just submerge the entire stream channel. And as you see there in the center picture. And then by the end of April of 2019, you can see how well the mat had vegetated. You got a lot of good growth there. And today that whole stream is just, it's kind of like a jungle out there. It's just extremely well covered and vegetated. And the mat's still there, reinforcing that vegetation. So just to wrap up the HybridTurf Instant Armor Mat, this type of product gives you 3 to 4 times the unvegetated permissible shear stress of your conventional TRMs and woven HP TRMs. And basically this just means less worry on how quickly you can get vegetation establishment on your site. And these products give you immediate rock-like erosion protection at typically less than half the cost of riprap. Sometimes it's much less than half. And they're more attractive, they cost less, they're easier to install than other hard armor type materials like tied concrete block mats and articulated concrete blocks. And being a simulated turf, they basically give your job site an immediate vegetated look. And then if the vegetation ever dies back for some reason, the site still looks vegetated. So that puts us to the Instant Armor Scour Mat. And the only difference between this product and the Instant Armor Mat, the turf reinforcement mat type product I just showed you, was this product we incorporate a 1/2-inch rubber core. And that rubber core basically adds ballast and weight to the product for use in more turbulent flow situations. That rubber core has 1.5-inch holes in it to allow vegetation establishment up through. And this product comes in a 3-foot by 4-foot panel, and those panels weigh about 30 pounds apiece, so they're fairly easy to handle. This product is an all-in-one scour mat, and what I mean by that is a lot of scour mats, other scour mats require some form of secondary underlay, such as sod or a turf reinforcement mat. This product does not require a secondary underlay. So you're going to basically apply seed and then install the panel directly over the seed, and then the vegetation grows up through the holes in the panel. Installation of the product is typically done with a 12-inch wire staple or rebar staple, and in some cases earth anchors are used if you've got a very loose soil condition, sandy soil condition, or a muck type soil you're trying to anchor the panel onto. Once they become vegetated, you simply mow over these to maintain the vegetation. These products have a very high unvegetated permissible shear stress rating, 14 pounds per square foot, which is basically the same as a 36-inch diameter rock riprap. If we look at the performance of this product as tested under the ASTM D6460 protocol versus some of the other typical scour mats out there, the purple line you see here is a rubber scour transition mat with a polyfiber turf reinforcement mat underlay, so kind of a combined system. And that type of product reached the 1/2-inch failure point at 8 pounds, or around 8 pounds per square foot of shear stress. The yellow line is a Tide concrete block mat, and that I actually showed you that we actually compared the Instant Armor mat to previously. And then the Hybrid Turf Instant Armor Scour mat is the green line. And you can see the Instant Armor Scour mat actually provide a little bit better soil loss control under some fairly high shears than the Tide concrete block mat did through the ASTM testing. Typical applications for this product: your culvert and pipe outfalls. Culvert and pipe outfalls is probably the #1 or most typical application for the product. But we're also seeing some other applications for the material where you have very turbulent flow conditions. That includes your shoreline applications, downshoots and such, and outfall areas. And then curb cuts on parking lots and where there's a lot of grade change, you got a steep gradient in soils you're trying to protect on a steep gradient with quite a bit of flow. And then downspout applications, which is a more recent application which has come up where they're using these mats under commercial downspouts, residential downspouts, where they're putting a mat down, and the mat basically absorbs the impact of the falling water and kind of distributes the water once it hits. These mats can be vegetated, and then you can simply mow right over the top of them. They don't have to be moved like they often do with, say, a plastic tray or other downspout protection devices. So culvert and pipe outfalls. This is a culvert outfall area that was done with the Instant Armor Scour mat. Picture to the left was taken upon installation. The mat was put down in fall of 2017. And then the center picture was taken about 30 days after installation. And you can see some of the new vegetation emerging up through the mat at that point. And then the picture to the right was taken the following spring. And at that point, the mat itself was pretty well covered in vegetation. Now, I mentioned curb cuts as a potential application for the product. Typically, you see this all over the place where at the end of these curb cuts, at the end of the concrete, they basically just dump a pile of rock. And what often happens there is the water finds its way around that pile of rock and begins eroding the soil between the rock and the vegetation around it. So this pile of rock also becomes, it's not only an eyesore, but it becomes a maintenance issue for the people that have to maintain the vegetation around it. These instant armor scour mats can actually be used in these curb cut areas. Put the mat down, let it vegetate, and then the person maintaining that area can simply just mow right over the top of it, and it looks much nicer than a pile of rock riprap. So just to summarize on the Instant Armor Scour Mat, this product requires no additional underlay, TRM, sod. That will save time and money in the installation. These products are very flexible, so they're easy to install and conform to the underlying soil. They're a lot quicker to install than like a tied concrete block mat. They don't require the heavy equipment to transport the materials as well as install or place the materials. And they're very flat once they're installed. So you get vegetation growing up through it, then you can simply mow right over the top of it. You don't have to worry about the mower blades catching a rock or a bump of concrete or what have you. And then once again, these products look vegetated as soon as they're installed. So they provide some aesthetic benefit as well. So I just want to thank you all for your time today. And if you want more information, please feel free to reach out to me. Contact information is on your screen, or you can also visit our website at www.insta-turf.com. Thank you.